got my hair cut. Now occasionally it wants to stick out the side like in, well, anyway. Got you on the stand. Hello, YouTube. Earth. What am I doing today? Well, let's see here. The finishing steps for my Escape Hybrid battery. I've already got all the Ford electronics on. Now, folks, I don't know what they're doing, but they've actually got like a ambient temperature line right here. I mean, it went all around the outer perimeter of the battery, and I actually had to fold the line because this battery is smaller than stock. Although the cell spacing may be a little greater and the diameter of the cells is about 3 millimeters thicker. Now for this battery, a little concerned. There is a blank space at the voltage output because of the other being 12 row. This one's 13. That's the way Ford built it. But the overall length going out may exceed the size of the original battery. Which means I'm going to have to cut the case to get this to fit. I've done some measurements. It's awful close, but I won't really know until I get it set in place. And today, just doing the finishing touch-ups on the base, because the base is, well, all the magic starts here. As far as stacking and then spacing between the cells for the other electronics like the dolly. The dolly active balance, they're working out great. It's been like a couple of weeks now. Everything here is doing fine. Now, I waited because I didn't want to jump the gun. Sometimes you can get an electronic item that's totally defective and ends up doing a weird discharge on the battery or one cell to make it go zero, even though the cell's fine. So I didn't want to take that chance and, put the car in retirement mode for a few days and then go to the car only to discover that I've got a cell row that's dead because active balance decided to drain one cell row or one cell. Not a good mix. And as far as this one goes, I got two cats, and one of them absolutely loves to cat nap on this battery. Well, he did me a favor. He found a cold solder joint, and I went to test it yesterday with my phone. Tap into Bluetooth to see what's going on, whether they're okay or not. All of them was okay except for this one. And come to find out, after taking a closer look, cold solder joint right here. I had to fix that. But it seems to be fine now. It was just reading low voltage, like all the cells were dead, instead of being 3.2 volts. Now, 3.2 and 3.3 is pretty much where they're maintaining at a idle state. Of course, they'll charge up to 3.65 volts. They are LiFePO 4 batteries. Really wish I had two of these together. But to set an example, I don't know if you can see this or not. Let me turn the thing around. These cells are incredibly long, and they sit like driver's seat and the cells sit going this way, two together. That's how they sit. So this is one cell, and it is about 3 inches shorter. But the problem that I'm possibly going to see is the 13 cell row rack being too long to fit in the cabinet. If that happens, folks, I'm going to take a Sawzall or jigsaw and cut that cabinet open, because this car is getting a cell upgrade. I don't care what I got to do to make it work, but it will get done. Unless something catastrophic happens and ended up costing me a few grand to fix it. No, I'm not doing that. I'll take the car straight to the junkyard. It's paid for. It ain't eating nothing. All I'm paying is insurance on it. This was the absolute cheapest thing I could do. And the sad part about it, even though I've done all this, these cells are not matched. I've got up to 1 amp hour difference between the cells. I was really, really hoping to get them matched, but it's not the case. So as I was saying before, if you buy these from Battery Hookup, test your capacity. If you absolutely, without a doubt, require that the cell capacity matches, then you're definitely going to have to test them. And if you don't come up with the right number, then you'll have to buy more until you do have the cells that match in capacity. That's one thing that I could not afford to do. I bought about 120 cells, right around there. And Battery Hookup, I told them what I was doing, and they donated, I think, 40 cells, something like that, to the cause. And I need to, that's partly why I'm doing the video. And I was planning on documenting this anyway. But he wanted me to send him some pictures after I get it done, or work progression. So, you know, I've got photos of this too. But this has been a long endeavor. It's a process. If you want to rush and put a battery together to put it right to use, well, you can do that. But you're not going to know if you're going to have any problems out of it until you start using it. Me letting it sit and keeping an eye on the active balance lets me Bluetooth in to see what the voltage is on the per cell run, and also it'll let you know if you've got any dead cells. These are compatible. The Dolly Active Balance are compatible for pretty much any grade cell that you got, whether it be LiFePO4, lithium ion, cobalt. It's different voltages. You just got to know the cell range for your voltage to do the balance. Lithium ion, according to factory with these, which is what they will set at to start, will set at 3.3 volts for active balance. Now, 3.3 volts is almost dead with lithium ion. So I seen that and I was like, okay, well, if they're considering 3.3 volts at almost dead for lithium ion, I'll just do 2.3 volts for LiFePO4. So I've got all these set at active balance to start active balance at 2.3 volts. When it dips below that, from what I've seen on the other, it'll stop active balance completely. It will not discharge the battery down to zero. Once those cells hit 2.2 volts, active balance stops. And when I soldered that wire back in place, the voltage spiked back up to 3.2. Active balance started again. So they're solid. I'll give them that, but they are expensive. I just cannot stand the price of them. Was a necessary evil. Agenda for today, I've already cleaned up these ends, and what I've done is 3D printed. I actually went into Blender and cut off the ends and left where it would wrap around the cell. So this is a stacker. It does snap lock in place, but the way I did it, I had to grind some of the ends off because they would not lock into place. They wouldn't fit between the cells. The idea, keep space between the cells for air spacing, and I'm not too sure if the Ford location on the fans is actually going to work. Now, from what I've seen on the Ford original battery, they really do not have that much spacing for an air channel to go through. It's kind of unexplainable. They've got the batteries are covered over. They're sealed up by plastic edge to edge. There's a plastic that goes over top of it for the air gap, so there's no airflow there. The ambient temperature line, I'm suspecting, is to, with the bottom rack, is to be able to monitor the temperature of the bottom cells, because that's where most of the heat is going to gather. If you have heat building up on the top rack, it's going to radiate down and also radiate up, but you've also got heat build up from the bottom rack that has nowhere to go except for the fans blowing a small channel of air through the center. Yeah, it blows a small channel. I think is about 4 or 5 inches wide, maybe 1 inch thick. Blows air through the battery, and then back around and in. There's 2 fans at the back of the battery. Now, those fans are known to fail. Of course, with me being a Deltec, I've seen those type of fans fail with no problem. It doesn't happen very often, but they are known to fail with that fan type. The bearings blow out of them. They fail. I haven't tested those cells yet. We've had a lot of rain. So I can't just take the battery casing out and cover it over with a tarp. It needs to stay absolute, without a doubt, dry. And that puts me working on this in the house, taking my sweet time because I want to make sure that these 2 racks are okay. But when it comes to working outside, well, I'm gonna have to work around the rain. According to radar today, with it being July 4th, Tuesday, we've got rain coming in Thursday. Once I get these racks, providing I have no problem getting these racks in the original casing, I'm going to have to leave it out of the vehicle so that I can wire everything in. I've already got the jumper wire. This is a jumper to go to the positive and ground, but there is a backup service plug that needs to be used to disable the voltage going to the car or to service it. This line will have to go to 1 pin, and then I'll have to make another line off of the other rack so that I can copy, if you want to say, or set in place to be able to use that disconnect. voltage out. Folks, I'm only going to use 4-gauge line. To be honest with you, the output line on the Ford Escape, I don't know what Ford was thinking, but it looks like about a 6-gauge line. According to the power on the electric motor and the calculation for the battery voltage, they're doing about 178 amp. That's an awful lot of power for a 6-gauge line. In other words, this is 4-gauge. The line coming out of the battery, the factory line, power line, going to the electric motor, out of the battery is thinner than this. I don't like that, but what can you do? It's Ford. They did it themselves, but it's working. It's hard to say how much of a voltage sag it's got once it gets the electric motor or the drive controller. And it's probably quite a bit. But what can you do? 0-gauge line on my part is really not going to do much good. The only thing I could do to help improve this battery is double up on the connectors from positive to ground to make a series connection. These connectors, the bars are only rated at 100 amp. And if they go over that, they will get hot. That will heat up the cells. But these also have a built-in temperature probe too. If they're mounted to a surface and they detect a higher temperature, that temperature probe will let you know the temperature. But it's going to be ambient temperature or whatever it's mounted to, but mostly ambient. I've already got the thermal probes in place for the Ford setup. All the plugs. Just basically need to do some tie down. And then start testing for the stacking. So, I just want to make sure that these boards, I do have them hot glued, but I want to make sure that these boards don't fall off. That one's probably going to give me a problem, being crooked. Yep, I can see that, so I'm going to have to move it. One cell over. Yeah, and I want this thing. I want to be able to free move it on all of them. Now, I've already arranged clearance on the same cell rows, at least I hope. That's why I want to test stack it beforehand. Because I don't want to get it out in that box and then realize, oh crap, yeah, I don't have clearance there. So, I'm pretty much going to have to set the batteries, flip the other one so it's sitting at the proper orientation, and then check for clearances for the piece of plastic. Alright. already got that one zip tied. That's good. Ow! Shock. Yeah, I can't tell you how many times I've been shocked by this, but yeah, it'll get your attention. For sure. Grab a few. One thing I might want to bring to your attention is I didn't want these boards sticking out on this one. I do have on the top rack, but no, not this one. This board actually has an inline fuse. It looks like it's rated at 3 amp. For some reason, they've got the outputs. They had them double banded. So instead of doing that, I just did a 14 gauge jump over to here. And with that being an output wire, and I'm having to work with this, when I got these batteries, some of them had just a standard screw head, like that. And then others had the nut type with the Phillips. So I'm doing the standard nut type on the battery post, except for down there, because that's I've already got a cable there, and I'm going to definitely use it. But the battery outpost, I'll be using the standard nut type on that, so I can have access to it. I'm planning on scooting the battery away, the short end, towards the driver's side, so I'm going to have a gap in between the voltage output stuff. Now the cabling, for the Ford cabling, it had plenty. There was plenty there, so no problem there. One thing about hot glue, it's good for short-term projects, kind of hold stuff in place. But what it's not reliable for is holding. And it looks like it needs a little extra help. Now, a good example on the battery length difference. This orange cable right here, it jumped across. These were spaced about an inch apart, end to end, and then they had this wire jumping each board over. So yeah, it's going to be a pretty big difference on the width of it. They are shorter, but the overall, from tailgate, rear bumper to the back seat, that's going to be the difference, because these cells, because of cell spacing and the diameter of the cells, is going to make the battery longer. I'm sure of it. glue a thermal probe down. Uh-oh. It's short. Yeah, I can't leave that unglued. Unplug it. The one factory cell that you guys just seen me put on camera, I pulled it off for a length comparison, and I also test charged it at 7.4 volts, and it did it just barely getting warm, which is normal for nickel metal hydride. They will get warm at 7.4 volts, but I've had some others that try to charge them to 7.4 volts and they hit almost 200 degrees. That's, yeah, those are bad cells. Zip tied, zip tied, zip tied, zip tied. These are glued. I'm gonna zip tie those suckers too. More. Now I do realize I haven't documented a lot of this build, but a lot of it was redundant. And those of you that have worked with these batteries before, they're pretty simple. You can screw them together end to end with the connector, or set them in a battery pack. And I don't want to pull too hard on that. Or just set them up as a different type battery. But they screw together end to end with a Allen wrench, thread bolt type deal. It's kind of like a thread. It's kind of like this threaded bar. They're probably about 7-8 inches long. I mean, not inches, but millimeter long, and have a Allen fitting in the end of it. So you put that in the end of the battery. I wonder if I got any. Let's see. Do I have any left? That is all the screws. Do I have any more of the inserts? No, I used them all for this build. Or at least that's what it's looking like. And some of you might be asking why I did not use a BMS with these batteries. It is because it's going in my Ford Escape, and they have their own battery management system. that will shut down the car if the battery is depleted. For that reason, I will not be using a BMS on the Saturn when I build it, or my Escape, because the controller has its own internal settings to shut down at a certain voltage. Therefore, a BMS is not needed. But it's a good idea to do active balance and also the overcharge pull down, the top balance boards. It's a good idea to have those too. Because, best of my knowledge from factory, like I said in I think in the last video, factory said these will not top balance. They will only balance between cells that are low to get them to match. That's it. So if they overcharge, well, you're pretty much out of luck. But as far as the motor controller goes, and even on my bike, and that being my first thing that I built, I'm actually considering taking the BMS out of it. I've got 2 of them. So that will be dropping the battery, removing both BMS boards, and let the controller take care of the low end voltage. Once it gets down to a certain voltage, it shuts down. That protects your batteries for the bottom end. But overcharge, I would have to switch out to the setup that I've got here. Top balance boards, along with the active BMS, along with the active balance, rather. I don't have any more of those threaded ends. I thought I had more. That's the ring terminals. Yep, nope, not happening. Anyway, it's like a threaded rod. You just put the 2 batteries end to end. They thread together, and it's pretty simple. But the only thing about it, you end up with tape measure, and I'll give you a measurement on that length with 4 cells together. I just seen it. Tape measure. Well, I just seen it. Aha! 4 cells together will give you about 21.5 inches in length. These cells, only one of them is 13.5 inches with these nickel metal factory cells. 13.5. So that's 27 inches long. But they are designed to sit driver's side wheel, passenger side wheel, 2 batteries together. And the overall diameter of the batteries from you guys see that? These are very exceptional cells. 9032 milliamp hour. That's basically a 9 amp hour battery. They're factory rated at 8, so this is most likely never been cycled. Now, the diameter, set that at 0. .3 for diameter. That's in millimeters. A lot of my measurements I do in metric, when it comes to this stuff. Now this is what I'm talking about on the diameter and the air spacing. That battery is going to be wider in that nature. I think I'll have no problem with the 12 row, but the 13 row is most certainly going to be a problem. This is 32.6 millimeter. So that's a difference of roughly about 5 millimeter gain in diameter. That's going to make it longer going this way. Okay, the way it sits in the car, here's the voltage. There, okay. Okay, battery out. This is a joining cable that goes over to the shutoff, the server shutoff on the top cover. And then your two outputs when you stack these together. I haven't stack tested this yet, which that's where it gets confusing because the other battery has to be flipped. It took me quite a bit to do some steering and focus and everything to get that sorted out. I almost built the batteries wrong for the polarity. Trying to figure out where I'm going to put both of these side by side to figure out where to do some comparison. Some light would be nice. Okay. As once said in the famous song, the heat is on. Alright. Well, I hate to abuse my coffee table like this, but it's got to be done. Oh, yeah, I forgot to zip tie my main cable coming out of the battery. Alright. Bottom right on the way. Positive battery out. PO. This is happening! Finally! Now, I think I had to park it in February. Battery positive out and the ground band. So that's positive to ground, upside down, that's awesome. And then on the end, talking about, oh, there I am. Okay. Here's positive, and that's positive. That's an immediate problem. Oh, wait. they get offset by one cell and the ground gets moved over. So that means my battery clearance for the stack should be here. Grab a marker. Just see that okay? You don't necessarily need to see my ugly mug. I could probably move this in closer. Hang on tight. Trying to get the whole image here, people. Okay, now this battery has to stack on that battery. This battery has a ground that bridges in from the back, moves up, it's a bar, and to be honest with you, it's actually not much thicker than what the bar is going across from positive to ground to make the series connection. Matter of fact, I can compare that right quick. Let's see, one of the bars that comes with the cells is 1.6 millimeter. As you can see, seeing is believing. Well, 1.5. I'm kind of pushing it in though. Alright. And the thickness on the factory bar is 2 millimeter. Yeah, 2 millimeter. So that's not much difference at all. It's pretty close. So I am not going to be concerned about doubling up on those cells. If it's good enough for factory, then I'll just make it good enough for me, although that's unacceptable because 178 amp, they're going to get warm. That's a given. Now I'll get my cables, Bluetooth, plug out, Bluetooth, and where is my other Bluetooth? Three, okay. I need to make sure I've got wire clearance on each. Battery cable out, that's cable out, cable out, Bluetooth, Bluetooth. There's only two for the top board because of that being an oddball. I had to buy a 4S active balance board to take care of 4 cells that's in the center of the battery instead of the end. I thought that may work out a little bit better because the ends, they take the most charge and discharge than the rest of the cells do. Now it's because of natural resistance. That's just the way it works. Alright, now I need a way to prop these so that I can see confusion. Alright, that's at the end. Not standing. And it's gonna smash my cable. Cables everywhere. This will be all set, so it's here. It looks like I got wires facing here. This will be offset by 1. It gets moved over that way compared to the other with the voltage outside. And flip my view. Well, the viewer just don't want to play nice. Looks like I'm all good to stack it. Okay, but as you can see by the timestamp, yeah, it took a pretty long break. I was getting kind of hungry, so I stopped to eat and watch a few YouTube channels I watch from time to time. Time to start the stack test. I feel this is necessary before I actually go to implement it inside the car. Hopefully the audio's okay. I don't know about this camera. Sometimes the audio's okay and sometimes it's not. I tried a wireless microphone and boy, that ooh, it was pretty terrible. All right. So here we go. Well, left don't want to agree with right. Put in this one. Oh, man, snap. That's not a good sound. what I got. Yeah, I knew it'd be a problem with floating, but not a lot I can do about that other than stabilize it after I get it in the casing. Looks like I got one that didn't even bother. Yep. One battery off. Well, one thing's for sure, I can't stabilize it by the outside and make the rack stay the equal distance with the lock design because they're opposite, male and female. If they were both male or female, it would be fine. Oh, Jesus Christ. Ooh, yeah. Big shot. Woo! Mm. Okay, now the way the factory battery sits, it's stacked on top of each other. I got plenty of clearance for airflow, and cell spacing will let heat dissipate through the top. Folks, I may never be able to put the top back on that box without doing some kind of adjustment. Get to turn around here a little bit. But that's how it's supposed to be. Now they've got V out here for ground. And then positive is here. The service connect is down here. And I've got the cable for it. Got to make a cable for the V out positive. The original factory battery had disbarred, so that's default. That's factory. I went on and used it. Hard to say what I'm going to have to do there, but I may have to cut it off, drill a hole, just cut it off like right here, drill a hole through it, and run a cable. But it's working. All my Bluetooth units will be on top. And that is most certainly thicker than factory as far as being stacked. But necessary evil. Gotta have those electronics. And I didn't want to slam these batteries together because of heat. Definitely want to get airflow through. I wonder, I can probably use Blender to make some kind of opposing stabilizer. Shame. That is a shame. Let's see. What can I do? Nothing. Yeah, I can't do nothing to stabilize it. Damn it, shock. Yes. Now my idea was to somehow bond my stand-ups. I could possibly do that with hot glue, but that definitely won't be a solid fix. Shock. Okay. What is that? At least 4 times I've been shocked since I started messing with this. Let's see if I can take care of that. Where is the Mylar tape? Aha. This is something I was wanting to do to start with. By the time I get done, that whole roll's probably going to be gone. Okay. That will help. Now, to protect the terminal post that's sitting at the top, Bluetooth. Bluetooth. I'll be if it ain't ripping out again. Okay, get to the other side and unstack it. And what? Ooh. Yeah, wasn't supposed to happen. Huh. Tape keeps ripping. What did I do? If you guys are wondering how I ever get anything done, because I'm always looking for stuff, you're right. Nature of the beast. Inherited by my dad's side. The boxes that are underneath the coffee table are actually batteries for the Saturn. Yeah. Well, yep, that's got one in it too. That's three. I've got another one over to the left of the camera. That's 4. I bought 6 total, and 2 is already ready, and I did a video on it not too long ago for charge test. Shortly after that, my Escape broke down, which is my daily driver. But back in October, I bought another car, planning on my Escape breaking down. A 2016 Chevy Trax. It's a nice car, but it's just not my Escape. The Escape rides better, handles better, the brakes are better. Plus, with it being hybrid, I should get better gas mileage, but with the old cell batteries, no, I wouldn't. Plus, the back gate has a back glass that opens. These new compact SUVs and SUVs, they don't have a back glass that opens. You got to open the whole tailgate, and it's just really inconvenient. Okay. Bluetooth. That's for the positive cable. I got a custody. And don't really know how long I'm going to need it. That's positive out. Ground out is over there on that bar. Am I getting shot? Oh, I'm touching that's why. Okay. Touching the ground and then the positive on the outside. This rack on the battery is about 156 volts. So yes, it definitely will get your attention. The whole voltage for both racks together, nominal is right around 320. But charges up to 379. Max charge. No, not 379. That was for 213 roads. So it's right around 360-ish. Center post. That is going to be protected by the foam. Ow, pinch. That'll be good center support for the top right battery to keep them from the post from getting bent. It's just about the perfect thickness. Plus, it'll even help stabilize the battery because this foam is just a tad bit thicker than the spacing that I've set up. And that is separated by the Mylar and also hot glue, so no problem with shorting there. Okay, I need to put this back on the desk and hot glue that foam in place because that's where it needs to stay. And of course, trim that one piece shorter. Yep, it's got some weight to it, folks. That ain't no joke. Okay, folks. Now, as you can see by the timestamp, it's several hours later. My battery died. Everything that I wanted to do today with these batteries is done. Next is loading them up in the case. Now, I've still got one factory battery, the 12 roll. I left it in the bottom because I didn't want to disturb it. Reason being is I needed it to arrange the Ford electronics around the replacement battery. So, as you can see, it's all done. I even put the foam on the battery. The test stacking it's what I expected, to be honest. I went on and put a cable out, crimped my ends. I've got a nice, where'd it go? Nice, not really cheap, but nice, crimper. Now, when it comes to crimping wires, I really don't like it, plus I've not really had a lot of luck unless I add solder. Yes, solder. So, you know, it's just one of those things. But anyway, those of you that have come along for the journey, I thank you. And I haven't really seen anybody document these Ford Escapes on this nickel metal hydride. I've seen a few videos where they tear the battery down, but what do they do with it? Who knows? What happened to the car that the battery came from? Who knows? So it's one of those things that, why aren't these cars having batteries rebuilt by the DIYers that may have a hybrid? I'm one of them. Am I the only one? Probably. Or the only one on YouTube. That's a possibility too. So I know this video's long. I've got it in my editor right now. This is the closing part. It's almost 2 hours. I'm going to go through it and do some clipping and fast forwarding on the long stuff that I'm doing to get it as short as possible, but it's going to be a long one. Yep, longest I've ever done. And, well, I guess I'll have to see if YouTube will let me post it. So anyway, people, I'm signing off. You have a good one.